top of them. But when you go down to Antarctica, you have polar glaciers, and they're frozen to the beds, and they are a different type of thing. And at the same time, it gives me a chance to tell you a little bit about Antarctica, and then also the geology that is down here. And so in my title slide, you can see here, at the bottom, you can see Antarctica. There is a little peninsula that goes up here right at the top called the Antarctic Peninsula. That's where all tourists go. And tourism started in 1950, but it has really taken off in the last 5 years. And I'll talk a little bit about that coming up a little while later. And so I lead trips around the world for the Smithsonian and for Stanford University and American Cruise Lines. This one was a Smithsonian trip. So we left from Portland, went down to Dallas to Buenos Aires, a couple days in Buenos Aires, and then you fly down to Ushuaia, and that's where all the boats leave from, and then they go across the Drake Passage there, and then you go up and down the Antarctic Peninsula, and they come back. Now they're also sending ships out of southern Chile too, so those are the two places that people come from. And so, let's see, I guess I did, oh, here's my outline of my talk, and then I'll go back and show you some of these other things. I'm going to tell you a little bit about facts about Antarctica, a little geography of the continent, a little bit about minerals and development. If you were to do research there, what would you do? You wouldn't do the trip that tourists do, and I wanted to show you kind of that at the same time. And then focus in primarily on the polar glaciers, the ice sheets, the dry valleys, and the ice shelves. And then if we have time at the end, we'll talk about the Ross dependency, where McMurdo is the South Pole, and then climate change. Here is a map of Antarctica. You'll see the big part is on the east part. It's called the East Antarctic Ice Sheet. And that's where the ice is the thickest, it is melting the slowest. And then in between, there's a chain of mountains called the Trans-Antarctic Mountains. A lot of them old volcanoes that you've got. And then you have the West Antarctic Ice Sheet. You have a couple ice shelves, the Ross Ice Shelf, which is the biggest one. And then you have the Fram one up here. And then you have the Antarctic Peninsula, which is an extension of the Trans-Antarctic Mountains. And that's where most of the tourists go today. Give you a feeling as to the size of Antarctica. Here is a map of the United States. And so it would fit in that. Actually, Antarctica is 2 times the size of Australia. And then if we wanted to compare it to the size of Greenland, there's the size of Greenland, which is much less than the United States. And so here is the map of Antarctica. I wanted to point out a couple of things too. First of all, as you cross from Ushuaia in South America across to the Antarctic Peninsula, you cross what is called the Drake Passage, one of the most difficult ship passages in the world. There are so many ships that have crashed down here in the southern tip of South America down here because a huge current that comes through here. And many times you'll have 40-foot waves that you got to go across. Normally takes 3 days. We did it in about 2.5 just because it was fairly calm this year. And then you go up and down the Antarctic Peninsula, and then you come back. The dot down at the bottom, next, that is McMurdo. That's the American base. The other American base that we have here is at the South Pole. And then we also have one up here at Palmer Station. And then if you go to Antarctica, you go through New Zealand. So you fly down here to Christchurch, and then you cut across to over here. So first of all, that line that I showed you, that line that is right here is called the Arctic convergent. The water on the inside is very, very cold. The outside is much warmer. And so the life in the ocean changes as you cut across that. Also, there is a current that goes clockwise around the Antarctica. The fastest, largest current in the world, 1 kilometer an hour. And so that's why it's so difficult to cut across the Drake Passage. And then there is always ice that is extending out from the edge of the continent into the ocean. It gets up to 1,000 miles out in the wintertime, and then up to 500 miles out in the summertime. That incredible current is 600 times the flow of the Amazon River, about 500 miles wide. and it's named after Sir Francis Drake, who was down there. Now, it's interesting, just in December, an American from Portland, Colin O'Brady, and 5 other guys crossed it in a rowboat. It had never been crossed before in a rowboat in such a fast time. They did it in 13 days, finishing on Christmas Day 2019. I'll come back to Colin a little bit later. There's a picture of them in their rowboat, and the seas there are not very easy, and so they did the whole thing by rowing. Antarctica, 98% of the country is covered by ice, and it's the world's largest continental glacier. The highest point on the island, on Antarctica, is 16,000 feet in elevation. The lowest point is 8,000 feet below sea level. It's in the Bentley Subglacial Trench, which is underneath the ice. They do have some island rivers, Onyx Rivers, 15 miles long. And then the largest lake there is actually underneath the ice, underneath the Vostok station, which the Russians have been studying. And it's 4,800 square miles in size. It's incredible. The actual size, as I mentioned before, of Antarctica, 2 times the size of Australia. And so the parts of Australia you got, first of all, you have the ice sheets. The ice sheets are up to 15,000 feet thick of ice, averaging 7,500 feet. The biggest one, then they have the ice shelves. I talked about Ross being the biggest one. Antarctic Peninsula, that's where we visited. And then you have 2% of the continent is actually not covered by ice. Those are the dry valleys, and I'm going to take you there just to show you a little bit about it. Transantarctic mountains that I cut right through the middle. They, to the east, almost all above sea level, to the west, mostly below sea level. And then remember, the whole continent has been submerged because of this weight there. And so here is the East Antarctic ice sheet on the right-hand side, West Antarctic ice sheet, Transantarctic mountains, and then the Antarctic Peninsula that is up at the north. East Antarctica has been labeled the graveyard of old continents. Remember, all of the continents came together to form Pangaea and then broke up. But actually what they've done, they've come together maybe 4 or 5 times, come together, break up, come together, break up over the 5 billion years of history of the Earth. And every time when they break up, they take a piece of the continent that they're attached to. And so the East Antarctic ice sheet has a big hunk of Australia on it, and another hunk of India, which was attached to it. Other places, seafloor that has been uplifted. The rocks East Antarctica are very, very old, from 650 million years back to 3 billion years old. The rocks at the bottom are primarily metamorphic, gneisses, schists, and granites. And then as you go up, then you get into more sedimentary rocks. There's still what we call Precambrian ones. And then on top of it, you have ancient tillites, old glacial till. And this is still in the Paleozoic era, 360 million years ago. And then the youngest rocks underneath the ice are 200 million years ago. Those were formed when this whole area was at the equator. And things were much, much warmer. Limestone is a warm ocean type of rock that you see there at the bottom. If we take away all of the ice, this is what the continent would look like. Here are the Transantarctic Mountains, the Antarctic Peninsula, West Antarctica, and then East Antarctica over on the other side. And how much of it is actually above sea level? Not much. The surface land underneath. Well, you've got isostatic pushing down of the ice. And you can see East Antarctica, a lot of it's above sea level, but West Antarctica, not too much that is there. But then again, if you melt all the ice, all of that will rebound up. Actually, down there, they only have 2 days a year. They have summer and winter. And the sun is up in the air all of the time from September 21st to March 22nd. And then in the wintertime, it is down and it is dark. So staying over in the wintertime, and there are 100 people that stay at McMurdo, it's a weird sense. Here is a map of the continent, and all of these are the different stations of the different countries. There are 14 different nations around the world that claim to have found or came a part of Antarctica. The United States is one of them. Great Britain, New Zealand, obviously Argentina and Chile, South Africa, etc. And these are the bases that they have down there. How did how did Antarctica get there? Well, 200 million years ago, Pangaea, the big supercontinent, broke up into Laurasia and Gondwana land 135 million years ago. And then Gondwana land started breaking up. It broke up into, started up in southern Atlantic Ocean, South America and Africa broke off. India, which is down here, it completely went to the northwest and uplit all of the ocean floor, uplifted the Himalaya Mountains. The last breakup was Antarctica and Australia breaking off from New Zealand. And then eventually everybody is where they are today, but they continue to move away. So again, the same map earlier, there is the Antarctic Peninsula, Ross Ice Sheet, Weddell and Ron Ice Sheet that is found up here. The Antarctic Peninsula, where most tourists go to, has different names. The Chileans call it O'Higgins Land. The Argentinians call it Tierra de San Martin. Americans call it Palmer Peninsula, and the British call it Graham Land. And it's a string of bedrock islands, mostly volcanic, that are all held together by grounded ice that you have got. Research stations of Argentina, Chile, Great Britain, and United States are all found there. Lots of fjords that are in between these islands, high coastal mountains. It kind of resembles the Andes Mountains that you have got. And so hopefully, maybe some of you have been there, and you go in and out on the western side. And here are the different ice sheets, Larsen A, B, C, and D. And I'll mention those breaking up in a second. And this is what the Antarctic Peninsula looks like. A lot of water, a lot of very, very steep rocks sticking up, a lot of glaciers coming down. And we were over there for 4.5 days, and 3.5 of the days it was nice and sunny. It was absolutely gorgeous. Now, Antarctica does have mineral deposits, but you can't mine them. The reason is all the countries of the world have developed have a treaty that says you can't mine it because it's going to be very expensive. It's going to impact the whole ecosystem. And the krill are the little shrimp-like organisms that are abundant in the water. They are the food for the whales and for seals, penguins especially. And if you reduce that, then you will impact the life that you've got there. There are reserves of oil and gas, obviously, some coal, iron ore, manganese, but you can't mine any of them, and it'd be very, very expensive to do that. Now, I wanted to mention that everybody talks about Antarctica being the 7th continent. We have now found the 8th continent, and that is basically, it's called Zealandia. The Glomar Challenger and the ship after that have been drilling the ocean bottoms around the world. And when you drill the ocean bottom, it's always basalt, basalt, basalt. But off of New Zealand, what have they been finding? They've been finding granite, granite, granite. You can see here in the photo of the Campbell Plateau, the Chatham Rise, the Challenger Plateau, all are granite. That's an old continent. The continent has sunk, and the only part of the continent that still remains there are the North and South Islands of New Zealand. And so since I used to live in New Zealand and I've visited Antarctica, I've now visited all 8 continents that are there. I also wanted to mention our good buddy Colin O'Brady, who went to Lincoln High School. He's from Portland, and he is an adventurer. He loves climbing mountains and setting records all around the world. And then a couple of years ago, 2018, he said, I'm going to ski across Antarctica, 932 miles, no support, just skiing and pulling a huge sled. And he did that. The last day, he was racing. Louis Rudel from the United Kingdom, he was 49 years old. Colin was 34. He did 77 miles in that last 32 hours, nonstop, no sleeping, and he beat the guy and set the world's record. Average temperature for him on the trip was a negative 30 degrees Fahrenheit with a wind chill factor of negative 60. Here's a picture of him. That's the sled that he was pulling, very, very heavy, and that's him sliding across the continent. Economic development down there has been going on since the 1800s. And originally, seal industry. They were huge numbers of seals down there, and walruses, not walruses, but they almost wiped out the major populations in the early 1800s. And it took a long time for them to come back. Then the whaling industry went down there in the 1800s. In 1931, there were still 40,000 whales. Today, there are only about 6,000 whales down there. And in fact, it was a lot less. They've come back since that time. And then fishing started in 1971. Today, Japan, Soviet Union, Norway, all are down there, mainly fishing for cod, herring, and whiting, but also now krill. They are taking the main food for all of these marine mammals that are down there, and people are concerned about that are down there. Tourists started in the 1950s, ships down there. This last year, there were 40 different ships that were there, 40,000 people that visited there. And then this next year, they're going to add additional 20 ships and take it up to 50 to 60,000 people. They started taking planes down there from Air New Zealand in the 1970s, but one of the planes crashed in 1979, and they stopped doing that. So if you were a scientist in the United States and you went down there, where would you go? And the US government pays for all of this. You would leave the West Coast, you would fly down to Auckland, New Zealand, to Christchurch, and then you would go over to Antarctica, to McMurdo. So you arrive in Christchurch. In Glenda and I used to live there, and we had friends that would come through, and it was always fun to see them. You get off the plane, you go and get your gear, and you all wear the same thing in Antarctica. And then you pack everything up. Now you generally have 3 or 4 days. You go see Christchurch, the Avon Rivers, go to Starbucks, get your last Starbucks for some time. Then you go back, you climb onto the plane, and it's a 5-hour plane ride over. Now, if you're in the luxury seats, this is what it looks like going over. But a lot of guys are on the cargo planes, and this is what it looks like. And some cargo planes, it looks like that. And I thank Andrew Fountain, a good friend of mine in the geology department. He has been doing this for over 20 years, and these are pictures that he has taken. Then you eventually arrive in Antarctica. You land just outside of McMurdo Base, and then Ivan the Erebus comes out, picks you up 15 miles an hour. It takes you into McMurdo, and here is McMurdo. There's Mount Erebus, an active volcano in the background, right there, only 25 miles away. And then here's another picture of McMurdo there. There's a science center. Everybody lives in dormitories. There are 3 bars. You got a lot of geologists there. You need to have 3 bars. They have a cafeteria. Everybody eats together in the cafeteria. The scientists, though, eat by themselves. The flight crews by themselves. The contractors by themselves. And the contractors have their own buildings. And you can also visit the exploration huts of Shackleton and Scott. They're down there, and I'll show you a picture of that. There's an icebreaker that comes in once a year, because remember, this is on the Ross Ice Sheet shelf, and they bring in the oil, the gas that is there, and then they also bring in wood, and they also take out all of the garbage. And so McMurdo has 1,000 people, scientists in the summertime, 100 in the wintertime. Palmer Station up the peninsula, 35 in the summer, 20 in the winter. South Pole has 35 in the summer, 20 in the winter. The Russians have 12 bases, and we don't know exactly how many people that are there. So the field season is from Halloween to February 1st. Dorm rooms kind of look like this. Here is the cafeteria where everybody eats together, and food is pretty good. Getting around then the base looks like this, all these different types of vehicles, even bicycles that you can use, because remember, it's the summer down there, lots of activities going on. So lots of things happening. There's McMurdo again that we have got. And then here's a picture of Shackleton's hut from his famous expedition down there many years ago. Now, most of us are used to glaciers here in the northern hemisphere. It's a picture I took on the top of Mount Moore that I was roped up with a friend here. Left-hand side, the United States. On the right-hand side is the Juneau ice field in Canada. And typical horns, arêtes, cirques that you can see up there. But the non-polar, these are non-polar glaciers. They're different from the glaciers found down there in Antarctica, because down there, everything is moving, but there's no water at the bottom. All these glaciers in the northern hemisphere and the Andes, etc., they're getting water on the bottom, so there's deformation, but there's also ice at the bottom. Polar glaciers are only just moving with the deformation of the ice. And glaciers create cirques, arêtes, horns, U-shaped valleys, moraines, and drumlins. Polar glaciers don't. Here is a picture I took of the Von Lewis Glacier up in Alaska. when I spent the whole summer up there. And you don't see those types of things, medial moraines especially down there. Here's a picture of me in 1973 as I left Switzerland and went up to Canada to spend 7 weeks on the glaciers. This is what I looked like 7 weeks later, coming off of my crampons on the Llewellyn Glacier. That was my beginning of my glacial history and glacial work, and I worked in glaciers there for 10 years. In Switzerland, I used to take my students to their own glacier. This is where Louis Agassiz discovered that glaciers were moving masses of ice back in the early 1800s. He was a famous Swiss geologist. And the glaciers in the northern hemisphere, when you have very, very steep fronts, it tells you it's advancing, like the Trion Glacier. This is from Switzerland. Or the Gorner Glacier, which is retreating, which is very, very low angle front snout. Those are all non-polar glaciers. And then we had the glaciers, the continental glaciers coming down in North America and in Europe. But in Antarctica, for the last 5 million years, it has been covered with ice. But the Antarctic polar glaciers are different. They're frozen to the bed. There's no slipping on the bedrock. And it's all deformation of the ice. There's no water coming out at the snout. It loses mass, but it loses mass primarily through sublimation, just evaporating off into the atmosphere, and then calving, and not melting of the ice. So as I mentioned before, the Antarctic ice sheet covers 98% of the continent. Thickest point, 15,670 feet thick. Average 7,000 to 8,000 feet thick. Therefore, it's interesting. It has the highest mean average elevation of any continent just because of this very, very thick ice sheet that is here. 90% of the world's ice is in Antarctica. 70% of the world's fresh water is Antarctica. And pushing, that whole weight is pushing down, and the bedrock is pushed 2.5 kilometers below sea level. And as I mentioned before, there are a lot of subglacial lakes. So I'm going to take you to the dry valleys, which are quite interesting. So here's the Ross Sea, and here is Mount Erebus over here. And this is McMurdo. This is the place where you fly into. Then you take a helicopter and you go to this area down here, which has no snow. It's the dry valleys. And the mountains keep all of the Antarctic ice sheet out. Now there are a couple, there's one big glacier coming at the end, another one coming through here. But these are all, it's very, very dry. There used to be a lake in here. And you can see the old beach line of that. That's Lake Washburn, when things were a little bit warmer in through here. Lots of gravel, and because there is a little bit of water, but not much. And here's the major glacier coming in, and when you walk right up to it, it is just solid rock. There's no water coming out of it, and the only reason it loses mass is because of just rock falling off or sublimating into the atmosphere. And so the dry valleys, some glaciers coming into the sides. Here's a helicopter. One of the few places that there is a lake the last month of the summer. And that's from a little bit of the melting of the ice in there. And hiking through there, you always got your ice axe. There is a little melting. You can see an icicle that is here, but it's very, very, very rare. My favorite place in the valley is the Oreo Mountain, which is a sandstone and dolomite on both sides. And it's actually a reverse of an Oreo that you've got there. And so Portland State has been studying the ecology there for 20 years, led by Andrew Fountain, our world famous glaciologist. But there is a little melting of the water, and they do have a little stream gauge that is right here, only at the end of the season. Everybody stays there. This is the main office that is here. You can see the tents. Everybody stays in a tent. And then you have lots of solar panels here. And these are the outhouses. Outhouses are very, very important. Now, it's interesting because if you do science here, everything that comes into this valley leaves the valley. And so all of the waste products from the outhouses is burned. And then all of the urine is collected, and then it is recycled. And if you do field work, if you go to a glacier up the valley, and you're out for 2 or 3 days, you got to take baggies with you and a pee bottle with you. And so it is a different type of environment for doing research, but you need to keep this pristine environment because you don't want to introduce a lot of additional bugs and things there. Climate in the dry valley, 10 to 20 cloudy days in the summer. The rest of the time it's sunny. You get about 6 inches of rain in the winter, not much more. There's patterned ground because there's permafrost there. And no crevasses in the ice. Why? Because it is deforming in the ice. There is a little bit of water at the end of the season, as you can see. But most of the time, there isn't any. And what they're studying are the diatoms that you can see here and some of the one-celled microbes that are here and how they are affected in this little bit of water that comes out for 1 month a year. And then also on the ice, as the snow melts down, you will have dust and gravel or sand that will kind of collect there. And it come in, and those are called cryaconite holes. And there is blue-green algae living there in that. You have a little ecosystem all by itself. Let's focus in on the ice shelves. Very important because this is where the climate is showing the greatest amount of change. Up north, I mentioned the Filcher-Ronne ice sheet, which is second largest. The Ross is the biggest one, and then the Larsen A, B, C, and D down south. And so here is the Ross. Here is the Ronne Filcher, and then here are the Larsen A, B, C, and D. And there are other ones that are around there. This is where the glaciers come off of the land and go float right in the ocean that are out there. So they come off the land, and it's just floating extension of the glaciers that are on land. And here at Larsen A, B, C, and D, as you can see here. But what's happening is you're seeing incredible calving. And Larsen B had a very, very large piece break off a few years ago, the size of Rhode Island as it broke off. Larsen C now has a big crack going right up the middle of it, and it too very soon will break off and come out. The Ross ice sheet on the other side had the biggest breaking off a few years ago. The Ross ice sheet is the size of France, 200 meters thick. The front that I just showed you is 370 miles long, 50 to 160 feet out of the water. 90% of it is below the water surface. First discovered by Sir James Ross back in the 1840s. And then he went all the way into Ross Island, and he named the 2 volcanoes there, Erebus and Terror, after his 2 ships that he had there. And in the year 2000, a huge iceberg broke off there called B-15, the size of Belgium, the largest iceberg ever. Here it is. Broke off, and it took many, many years to eventually break up and form smaller ones. And you can see as it broke off, and then it went down the coast, and then eventually broke up. And so let's see. Oh yeah, so I'm going to take you back down here to Ross Island. This is where McMurdo is. You come in, Scott Base and McMurdo Base are down here. Scott Base is where the New Zealanders go. McMurdo is where the Americans go. There's Mount Erebus. There is Mount Terror up here. And I'll come back to that. First of all, there are 4 active volcanoes on the mainland of Antarctica. They're all in the Trans-Antarctic Mountains. The Melbourne Glacier, Berlin, Kaufman, and Hampton Glacier. And the Hampton is actually a caldera. But then back in 2017, Edinburgh University Geology Department geologists found that there are 91 more volcanoes that are below the ice, added to the 47 that you have there. So we have, very close to 150 or 138 volcanoes in West Antarctica and in the Trans-Antarctic Mountains. Some are active. That means they've gone off in the last 10,000 years. Some are dormant. That is, they still have a magma underneath it. Some of them are extinct. Now here on Ross Island, Erebus and Terror, interesting volcanoes. The bottom part is a shield volcano. The upper part is a strato or composite volcano of andesite. So different phases of eruption of magma that is coming out of it. Erebus is 12,000 feet in elevation, and it is 1.3 million years old. It's recorded 10 volcanic eruptions through time. McMurdo, as I mentioned before, 35 miles away. And in 1979, Air New Zealand had a 747 plane that was coming over, and it crashed. 257 passengers killed, and they have not had any plane tourism there at all. Here's Mount Erebus with lots of snow on it. Here's Erebus with Terror in the background and steam coming out of it. It is an active volcano there. Did you know that there are 3 South Poles? There is a geographic South Pole, which is 90 degrees south from the axis of the Earth's rotation. There's also a geomagnetic pole, which is 78 degrees and I'm not going to go into it. And that's where all the auroras, the southern lights, come into, is where the Van Allen belts come in. And then there is a magnetic South Pole, and this is off of the Adelaide coast, and this is where all of the compasses point to. The geographic South Pole has an elevation of 9,300 feet elevation, and it's more than 800 miles to the open sea from there. 9,000 feet of ice underneath it, and it's moving about 10 meters a year in a northwesterly direction. It's much colder than the North Pole. Why? Because it's higher elevation. It's 9,000 feet elevation, and so it's essentially a continental climate. The highest temperature ever recorded there, 9 degrees Fahrenheit, and that was on Christmas in 2011. The lowest temperature, negative 117 degrees Fahrenheit, 1983. And it gets about 7 centimeters of snowfall a year. It's very windy, and that's only 3 inches, so not much snowfall there. There's a picture of the South Pole, or the American flag, because we have the base there. There is the whole operation, see there, and that sign I showed you is right there and back. And then very close by is Vostok Station. This is where they are drilling. You can see the drill rig right over here, drilling down into Lake Vostok, which is it's the largest of 400 subglacial lakes that are found in Antarctica, sealed off from the underneath the ice for 15 million years. Now, Vostok has an elevation of 11,444 feet elevation. The water is 1,300 feet below that. And so the lake is 1,600 feet below sea level. They kind of gathered it was there, but it was confirmed in 1993. What they have found is it's low nutrient lake, high in oxygen and nitrogen, but not much carbon in there. And now they are finding microbes down in there. It's the 16th largest lake in the world, 6th by volume. So it's amazing. And you've got 400,000 years of climate record in there. And eventually the Russians will get into all of that. Climate has been changing over the last 2.8 million years. And the temperatures get cold, they get warm, they get cold and warm, etc. And this is time zero, and this is 80,000 years ago, 40,000 years ago. The last major climate cooling was from 22,000 years ago to 12,000 years ago. And geologists have been telling us that. But what we are finding is that the West Atlantic Antarctic ice sheet and the shelves are collapsing. And if they were to all shrink up and collapse, what would it do? It would raise sea level. And what we're seeing right now is we're getting huge changes in the edges of the glacier. No, we aren't seeing changes in the edge of the glaciers. And climatologists said, oh, nothing is happening in the South Pole. It's all occurring up at the North Pole and on Greenland. And not much calving is occurring on, so the rate of climate change is less than the Arctic. But, and here's an example in the dry valleys. Here's a picture taken in 1911. Look at the rock right here. There's the end of the glacier in 1996. There's the same rock. The snout of the glacier hasn't changed. Geologists always look at the snout of the glacier. If it's going up valley, it's losing mass. If it's going down valley, it isn't. Well, none of the glaciers are moving. And they said, not much is happening. But what they said, we got to look at the ice sheets, and the ice sheets are thinning. And then they said, holy moly, we are losing huge amounts of ice. It's at the bottom of the ice shelves. And this is a multinational study that is going on. 1992 to 2002, we were losing 43 gigatons per year of ice. But between 2012 and 2019, it was up to 220 gigatons that are there. And so that is incredible. If the whole Antarctic ice sheet melts, sea level around the world will rise 200 feet. Also, Bird Station, which is another one of our stations in the West Antarctic ice sheet, it is a mile high. And between 1958 and 2010, the air temperature, average temperature there, increased 2.4 degrees Celsius. So it is warming down there. And then if we go up to the Larsen B, breakup here is the Larsen B. Look at this huge breakup, the size of Rhode Island that broke off in the past. And here is a map of the ice changes that we have got here. primarily the West Antarctic ice sheet, especially out here up the Antarctic Peninsula, not much on the east side, except this area right over here on the east side. So the ice shelves are the things that are melting. And they're actually under ice rivers that are there. The grounding line where it meets there is moving faster and faster inland. The Thwaites Glacier, which is up there in that highest area of melting, there is a huge cavity just reported just last year, a year ago in January, under the Thwaites Glacier, 2/3 the size of Manhattan, 1,000 feet high. People did not realize that. And so what's happening is the ice is going in like here, the ice shelves are thinning, and most of the melting is occurring in the west side of Antarctica. So that is the story of climate change that we are concerned about there. That is the story of glaciers in Antarctica and the geology of Antarctica. And if you are interested in touring down there, the chances of going there. So that is the story. Thank you, Rick and Sylvia, for giving me the invitation to come and talk tonight. Thank you to all of you, all 50 of you who have hung with us until the end. And now what we will do is open it for questions. And, you know, when we run out of time, all of a sudden the screen may just go black. And so we'll maybe do a couple questions here. And Sylvia, if you could unmute yourself, and if you see any questions in the chat box, fire away.
Yes. This one was not a question, actually. It was just saying I can't get the audio yet, but can see you and Scott. So hopefully they were able to get that. So there's a menu down below, those of you who aren't as familiar with Zoom, and there's something called chat and has the little air balloon. So you can just type in something down there if you have a question for Scott. Well, Scott, thank you very much. That was fascinating.
I just wanted to explain the final slide.
Yes.
On the hand side, Andrew Fountain from our department. These are all of his students. They were studying down there. It was their last day in the field before they came in. And I just think it's a great picture of, and I thank Andrew for some of the slides that I showed here tonight, and for being on all the committees of all of his graduate students for the last 20 years while he's been studying down there. And so no more questions, right? Yeah, it doesn't look like much in the chat room.
Well, let's see now. We're getting a few. Let me bring it up here. Next. Okay, this one is from Chris Gunterman. He's saying, I believe it's, what is your next meeting going to be and where? We will let you know. Be sure that you're on the monthly mailing list. We send out the constant contact. And like I say, this is the first, so we're hoping that we can have something each month until we can all get together again. So Eric Eason, if we halted all CO2 emissions today, how long would it take for Antarctica to stabilize?
Well, it won't stabilize. It'll continue on down. And that's what we're trying to do is climate scientists all around the world in all the countries have noticed that if we don't make changes in our habits of burning fossil fuels, and then the whole system, and just this last week, the new predictions on temperature in the year 2100 and sea level by 2100 will be 3 feet higher than it is today. That's very significant, especially for countries like the Maldive Islands that are right at sea level. And so it is happening faster. What we just want to do is each one of us take in the responsibility and use less fossil fuels. So, and switch to alternative sources.
All right, from Bill Burgle, could you explain how the ice sheets move, or do they? Now, Bill came in a little late. I don't know if you covered that before or not, but could you give him a quick?
Bill, good question. The ice sheets, the ice is actually moving and is deforming in the ice. The bottom is frozen to the ground, and the ice is actually moving up there very, very slowly, but it is still moving. there. And so because it's not moving at the bottom, it's not eroding, it's not picking up sediments, it's not transporting sediments. And there are very few places where things can fall onto the ice except in the Transantarctic Mountains. And so they carry very, very little sediment load in it, whereas our non-polar glaciers that we have all around the rest of the world, they are loaded with sediments in the ice at the bottom and then on the top. And so different ball game that you have got. You don't get big, huge, nice moraines, lateral moraines and terminal moraines and things like that. It's a good question. So they're frozen to the base.
Okay.
All right, from Martha Dennis. If all of the ice in Antarctica melted and the landmass would float up, would that compensate at all for the sea rise?
Yeah, and so what would happen is sea level would rise 200 feet, but the actual isostatic rebound of all of that coming up would be way more than that. Way more than that. And then just a good example is Hudson's Bay. Hudson's Bay had huge amounts of ice, not quite as much as Antarctica during the last glacial period. And then every year, Hudson's Bay just keeps getting smaller and smaller and smaller as that land, even 12,000 years later, is still rising up. And so I saw a talk on this in the predictions, and they said that the majority of Antarctica would be above sea level. Yes, good point.
Chris Gunterman, he sent a correction here. He had meant to ask, when and where is Scott's next tour?
Well, Smithsonian has me scheduled to go to Alaska, and it is a trip in August of this year, and it is primarily visiting Denali, Wrangell St. Elias, and Kenai Fjords. My annual trip to Iceland was canceled for July, and I have a feeling that the trip to Alaska will be too, but who knows what's going to be happening in the world there. And then I have been hired to go to Patagonia next year, I think in February, which is, and again, you would go around through the Drake Passage from Buenos Aires to Chile, and then get on land, and you get a chance to go to one of the most beautiful places in the world, the Torres del Paine, which I love, the highly glaciated area of the Torres. So that those are the only two that I've been hired for. Everything keeps getting canceled. Thanks.
Yeah. Ken Mansky would like to know, when was the last eruption of either volcano on Antarctica?
Oh, Erebus. Well, Deception Island has had one about 15 years ago, and then about 50 years ago. And so on the cruise that we were on, we actually took the boat right into the center of part of the caldera, just like Santorini in the Mediterranean. And we could just see where the last eruption was and all the debris flows that came down. And that was only 15 years ago. And so Deception Island, I think, is the last one there. Erebus has had some small steam eruptions just in the last 20 years. So, yeah.
Jerry Tunstall, Scott, could you give us an update on the continental glaciers of Iceland?
Oh, wow. The glaciers in Iceland, they're all melting. They're all receding, getting smaller and smaller and smaller. And, the largest ice field in Europe is actually Vatnajökull, which is in the southeastern side of Iceland. And so which we hope is we don't get any more eruptions underneath the ice, which will add to an additional melting in that particular area, and then Jökull Alps that will be formed in that area. Interesting thing about Iceland is it looks like an eruption. Magma is coming up very, very close to the surface. Lot of very, very small earthquakes occurring very close to Reykjavik and Keflavik, which is the airport. And so everybody is watching that right now. And maybe, how about one more question there, Sylvia?
Bill Burgle wanted to have an update on the volcanoes in Iceland, but he also says, what was PSU's focus there in Antarctica?
I love it. So we had three faculty members, two main ones there. Andrew Fountain has always been working in the dry valleys, and they have one of these National Science Foundation ecological grants to study the total plants, animals, and geology and hydro system of the whole ecosystem of the dry valleys. He does the water, he does the ice, and then the biologists do the other side there. And so that has been his focus there. Christina Hulba, who was in our department until about 5 years ago, she was our department chairman when she left, and now she's the dean at the University of Otago in New Zealand. She studies the Ross Ice Shelf and the thickness and how it's reducing and what's happening there. And then she took 1 year, Ken Cruikshank, another member of our faculty down there, to study the ice shelf. And so those are the two foci of the Portland State work that has been going on down in that area.
Wonderful. Well,
Sylvia, we didn't get blown out of here after 40 minutes. They gave us a few extra minutes of 13 more minutes of free time, and that's great.
Yes.
So thank you for the chance to come and talk.
Well, thank you so very much.
Thank you, yeah.
Reactions down here, so we'll give you a hand clap from us. So.
And you'll have to wait till you're back into the Heritage Center to get a jar of jam.
Oh, okay.
Thank you everyone for coming. I think it's been a great success. Thank you so much, Scott, for a wonderful program. Really appreciate you kicking off our Zoom meetings. And we're getting thank yous from people popping up on the screen here. Yes, 5 or 6 thank yous from people. So thank you everyone so much. And we will send out emails and let you know when our next meeting will be. So that
Stay
ends
safe, everybody.
Thank you.
Scott.
And Scott, thank you all for coming.
Well, thanks,
Thank you.
Good group.